Hello, everybody, and welcome to our webinar entitled Designing Dust Collection System for Woodworking. We are happy to have you with us, not only the attendance here in Zoom, but also we're broadcasting live to our account, our platform in LinkedIn. So welcome, everybody. I am Andy Biancotti. I will be your moderator today. We also have here in attendance Matt Coughlin, who is the owner of Backhouse and a Backhouse expert, and Dominic Del Santo, who is our sales director. They'll both have some parts here in the webinar. All of our team here at Backhouse is happy to have you with us. We know that many of you have very busy schedules, so we appreciate so much the fact that you are here with us, dedicating some of your time to this webinar. We'll try to make it worth it. A few announcements before we start. As you think of questions throughout the webinar, feel free to write them in the chat box. And as we can, at the end of this session, we will be able to answer those questions in the Q&A session. We will have the recording after this webinar ready so that you can watch it on demand. So we'll forward it to you the recording after the webinar ends. And if you would like at this point to invite some colleague or friend or someone that you think will be interested in the content of this webinar, we're pasting the link, the connection information so that you can forward that to them right now. All right, so what will we cover in this webinar? We're going to start today's webinar with reviewing some common woodworking processes where dust collection is involved and needed. And also, we'll get into our 4 primary components of dust collection design, and we'll finish up with a Q&A section. Please note that it takes years of education and experience to become an expert in dust collection system design. The goal of this session or this webinar is to simply give you an overview of it. But before making any big decision on your system, please consult one of our experts on the details, right? All right, so for the next part, we have Matt Coughlin, so we want to give him our attention. He will review some common woodworking processes where dust collection is involved. Matt, you have all our attention.
Thank you very much, Andy. So I guess I'd like to start by talking about why is dust collection and dust control important in woodworking shop. So I think the answer is pretty obvious. Nobody likes to work in a dusty shop where you have accumulated dust on the floor, on surfaces, you're breathing it in, it's very uncomfortable, right? So pretty clearly, dust collection is critical just for a comfortable working environment when you're in a wood shop. Depending on the size of the shop, if it's anything bigger than like a garage hobby shop, you also have some regulatory requirements. So you have your OSHA requirements, and then you have NFPA, which define all the requirements for combustible dust. And if you have a wood shop, basically it's pretty well guaranteed that you fall under the NFPA 660 and 664 requirements for combustible dusts, because wood is combustible dust. So you have to comply not only with OSHA's general duty clause and all the OSHA requirements for dust collection and combustible dust, but you also need to be aware of NFPA and make sure that you have the right safety devices and controls in place for your wood shop. So that's regarding combustible dust. And then we want to talk about just, how do you make sure that the dust collection is sized right, set up right, and functions correctly, and make sure you have a comfortable and safe working environment. So moving on to the next slide here, woodworking industries, we've worked with all kinds of different wood shops, basically from small high school type wood shops with a single, very small collector to military installations. We just finished several big projects and we're in the process of completing several projects with DLA and Marine Corps logistics-based box shops. So these guys are doing basic woodworking, saws and drill presses and the like, cutting and fastening lumber into crates and boxes. So big dust collection systems in place. We've also worked with cabinet shops, all kinds of stuff. So any type of woodworking from really rough machining and milling to more finely engineered wood products where there's a lot of polishing, sanding, generating finer dusts. Kitchen cabinets, furniture, all that kind of stuff all falls under the rubric of woodworking shops. And the dust collection system approach varies a little bit depending on the type of processes that are in the shop, but overall the approach is similar. We may adjust some things based on the materials, if we're working with hardwoods versus softwoods or engineered lumber. If we're talking about collecting heavy chips and things like that versus very fine light dust, that might inform our decision on how we size the dust collection system, the ductwork, maybe some filter media decisions, but overall the approach is pretty much the same. So on this slide here, you can see kind of a general wood shop. So you have a dust collector or a couple of dust collectors. We have ductwork that pulls the collected dust from the processes. So you might have chop saws or miter saws, panel saws, polishing stations, all these places where dust is being generated. You have collection hoods at each of those process pickup points. And then you have engineered ductwork, which is sized and designed to pull that dust out of your shop and out of that process through the dust collection system using a system fan or blower, and then exhaust clean air either outside of the facility or, and we can talk about this a little more later, or potentially recycle it back into your facility to maintain pressure in the building or to help lower your heating and cooling costs. So that's kind of a general wood shop you see there, pretty typical elements that we'll commonly see. So again, common processes may include milling, joiners and planers, cutting, sawing, drilling. Basically, anytime we're making chips or sawdust in a wood shop, sanding and filing. So all these processes are pretty common. They'll may, depending on the process, might change our approach to sizing of the hoods and the ductwork next to those processes, but overall, it all feeds into the same type system design. Size of wood dust is important. So you've got your class one light fine dust. So if you're doing sanding and polishing, what happens is the dust is much lighter. You get airborne dust, tends to kind of fill the shop air space if it's not collected properly. And it also has a much lower required velocity through ductwork potentially. So when you're talking about making sure that your dust flows properly through your ductwork, it's important to understand what class of dust you have. If you've done a dust hazard analysis, you probably have some data on the bulk density of your dust, maybe a mix. But in any case, it's important to know so that you make sure you have enough velocity through your ductwork and you also have the right filtration system in place. If you're doing a lot of or only light and fine dust, maybe you don't need something like a cyclone pre-separator upstream of your baghouse. But if you're doing a lot of class three, big fibers and strips and chips and things like that, it's probably more efficient to have a cyclone or something like that in your dust collection system. So those are some of the things that we think about. Um, System design considerations. So when we look at designing a dust collection system, again, we'll look at the dust type and size, fine versus big bulky dust and chips and so forth. We'll look at moisture content, and this may be, normally is not a huge factor when we're talking about wood shops, but it can be if you have a lot of moisture that can impact the filter media. We would want to know that up front. Um, Presence of other materials, plywood and particle board. I would say even more important would be like nails and staples and things like that. If they have a potential to make their way into your dust collection system, it's very important that we know that up front when we go to design the dust collection system. Application or machinery, we design a system starting with every single pickup point. So that's every machine in your shop. We would do a layout and we want to start by identifying the size and type of pickup points so we can start sizing the ductwork and eventually sizing the whole dust collection system. Intermittent or continuous duty, and I think we'll talk about this a little bit later. So most wood shops are not operating with every machine working 24/7. You use your panel saw to make a few cuts typically, and then you'll move over to the miter saw, and then the panel saw sits idle for a while. That's more typical to the way a wood shop works. However, typically our approach would be, and this is in line with industry best practices, to assume that all of the pickup points are open at a given time. And then the intermittent continuous use, you'd use blast gates and a VFD on your fan, depending on how complicated your system is to adjust your system for balancing. Volume of dust is important. We want to know how much dust is being captured by your dust collection system so we can appropriately size the bag house or cyclone if we're putting one in there, so we don't overload the dust collection system. Material handling, oftentimes in wood shops, the dust we collect just goes into drums or sacks or dumpsters just to get disposed of. And that's pretty simple to do. However, there's other things you can do. You can collect that dust and you can move it into a silo or some other process through material conveying systems for recycling or reuse or some other part of your process. We would want to know that up front so we can design that into your system as well. Total cost of ownership is an important concept. Basically, that means, more than just the upfront price tag for your system. What's the total cost over the long-term life cycle of the dust collection system? So we may, spend a little more on a VFD for your fan up front, for example, which may save you energy costs over time and result in a lower cost of ownership. Things like that we want to look at. We look at the whole system in the long term to make sure that it's the best, most efficient system at the lowest total cost of ownership over time. And then, of course, we've got the combustibility factor, and I'll talk about that on the next slide a little bit. So if you go to NFPA standards, they're all referenced in your OSHA requirements. But basically, if you have combustible dust present in fine enough particles, you have basically the three elements of the fire triangle in a wood shop. You have oxygen, which is always present. You have the fuel, which is your sawdust or wood dust. And then all it takes is an ignition source, which could be a spark from one of your processes, maybe a bearing on a cutting wheel or something. It could be a nail making its way through a saw, and that has the potential to make its way into your baghouse, your ductwork, and start a fire. Again, that's one of the two big risk factors. The other one is explosion risk. So when you have that same fuel or sawdust, which is then dispersed, so it's airborne, and then it's confined, so that could be confined in the baghouse or in your ductwork, then you have all five elements for a potential explosion. So that's when the NFPA requirements for explosion venting, isolation, spark detection, and extinguishing come in. So it's important that if you have a wood shop, you're aware of your combustible dust being present. You do a dust hazard analysis. You bring in someone who's familiar with NFPA requirements to help you design a system that's going to be compliant and, most important, safe. So for the next section, I'm going to hand off to Dominic Dal Santo, and he's going to talk about system design for woodworking.
Thanks, Matt. Okay, so now we're going to discuss some particular design considerations when we're designing a dust collection system for a woodworking application. So many of the principles are the same as any other dust collection system, but we'll go through the basic steps and we'll highlight a couple of those special things to keep in mind while designing your dust collection system for your woodworking application. So with all dust collection systems, the first thing that we're going to need to know is the airflow. The amount of air that you need to clean and recirculate or exhaust out of your building, that determines how large the system is. So the very first thing we need to calculate is how much airflow do you need in your system? So airflow is usually measured in CFM for us, so cubic feet per minute. And then sometimes we specify it with ACFM, which just corrects for things like altitude or temperature in case it causes the air to be more or less dense. So we're just going to call everything CFM, cubic feet of air per minute that we need to clean. Another important consideration we have is the velocity of the air. So we measure that in feet per minute for dust collection systems. Now, an important characteristic of these two, of figuring out the airflow, is the volume. So that's the cubic feet per minute, the airflow, the velocity, and then we have the size of the ducting. And if we know two of those three things, we can calculate what the other one is. So a normal formula that you might see is Q, meaning airflow, equals V, velocity, times A, area. So for example, if we are moving our air at 4,500 feet per minute, if we move that through a 4-inch round duct, we can look up our charts and see that that is going to produce 395 cubic feet of air per minute. If we were to go up to a 6-inch duct at the same velocity of 4,500 feet per minute, then we would have 888 feet per minute, or cubic feet per minute, sorry. And conversely, if we were to slow down the velocity, say go down to 3,500 feet per minute, in the same 4-inch pipe, now you'd only have 305 CFM as opposed to 395 before. And if you had a 6-inch at 3,500 feet per minute, you'd only have 685 CFM versus 885 CFM at the 4,500 feet per minute. So what's the point of these numbers? It's just to show that the number of ducts, the size of them, and the speed of the air going through them is what will result in more or less airflow. Now, in most dust collection systems that are for woodworking, we have a little bit easier of a task ahead of us because to calculate the airflow, what we need to do is figure out how many sources of dust we have. So in your application, it would be how many machines do we have that are going to make dust and need dust collection attached to them. And then we have to try to figure out how much dirty air is that machine making that needs to be removed every minute. So this takes us to the hood design or the ventilation design for each pickup. Now, with woodworking, what's really useful is that most, if not almost all, of the machines that you will be using, the people who make those sanders, planers, CNC machines, whatever equipment you have, chop saws, they're almost always going to do the ventilation or hood design in the machine before you buy it. So when you buy your sander, when you buy your planer, it's going to pretty much come ready with the dust collection hoods or the ports built into it. So that makes this part, much easier. All we really need to do is look at the machine and see what size is the port or how many ports are there for dust collection on the machine. Now, it may say in the manual how much airflow you need to provide for dust collection, but even if it doesn't, if you go and look on the machine and you find, for example, that there is a 4-inch round dust collection port sticking off the back of your chop saw, for example, that's your key to figuring out how much airflow you need. Because the air velocity, as we'll discuss in a second, is almost always going to be the same, about 4,500 feet per minute, 4,000 feet per minute. So if you take that velocity and look up a 4-inch duct with that velocity, you will get the volume of air that needs to move through it. So for a 4-inch duct, like we said, 395 CFM. So what you do is take a count of all of your machines that you have. Once you have the count, then go and you see how many ports and what size ports are already built into my machines. Make your list, and then with that in hand, you can go on to the next spot when we start designing the duct, and we can calculate all of them together to get the right amount of airflow for the whole system. Now, just a quick review here. What we do with the hoods, there are instances in woodworking where we do have custom ventilation, custom hoods and pickup points. What goes into designing a hood? Well, a proper hood or pickup point is not simply an open pipe directed at a bunch of dust. Anyone who's ever tried to just have a piece of flex hose sitting next to a chop saw will know that that doesn't really work very well. In fact, the designs of the hoods, how they're shaped, how they're oriented, how big they are at the front, how small they are at the back, all of those are very carefully engineered to make sure that we maximize the efficiency, the way that it sucks in the dust and the air. So a couple of common designs, you'll usually see tapered hoods where you have a big opening at the front that then tapers down to a small bit at the back. Sometimes you have flanged hoods or bell mouth hoods as well. You will occasionally just see a raw edge, which is just a pipe pointing at something. Those three are not very effective and create a lot of inefficiencies and waste. So A properly designed system will use a tapered hood design or some kind of specialty hood for certain very particular machines. And what's the basic idea? Most people think of a hood overhead pulling the dust up above them, kind of like what you would see at a restaurant in a kitchen where the smoke gets pulled up. And that works for smoke in a kitchen because the smoke wants to rise. But often in woodworking applications, the dust is big, heavy pieces of dust or sawdust. It doesn't all naturally want to float up. Many of it will fall down. So for that reason, the hood is not always above something. Many times it's off to the side and the air is being pulled in sideways. So this could be something like where you have a grinding wheel or buffing wheel where the pickup is behind you or across from the worker. And that's because it's pulling sideways. It's easier to pull the dust into the duct, pulling it sideways than it is trying to pull it up against gravity. But in any case, wherever the hood is designed or put into, the idea is that it's capturing all of the dirty air and all the dust that's generated at each source. Now, once we start going into designing the ductwork system, like I said, we need to start by making a layout of the machines in your area that are going to get connected to the ductwork. So we can see a sample image here, how one might lay out the ductwork. This is more of a graphic, but it can be simple hand sketch, just showing the locations of each machine relative to the outside walls, and then showing the distances between each machine. And then if you already kind of know where you want to put the dust collector, you can draw that in. And then with your dust collector provider, you can discuss where the best location is. But if you know that needs to go here, for example, you can then begin to work on the layout. And as I said, we're going to take an account of the number of sources or pickups that we have, or a number of sources, so the number of machines you have, and then how many pickups are on each machine already. If you have a machine that doesn't have a dust collection hood built into it, then we need to talk about that with your dust collector provider, your ventilation ductwork expert, and then they can work out with you what kind of hood that you need for that particular source. But for the majority of them, like we said, that'll already be built in to the machine. So all we need to do is count how many we have, and then we need to tally up the sizes of all of them. So a typical list might be something like this. You might say you have 2 sanders, a planer, a joiner, a chop saw, and maybe a floor sweep. So you have the list of your pickups. But then next to that, you would have sander, 2 4-inch ports, sander, 1 8-inch port, planer, 2 6-inch ports, floor sweep, 1 3-inch port, etc. Then when you have all the lists together, we can look at our charts with your dust collector provider, and you can see how much CFM each of those pickups, each of those sizes requires. How do we know which one? Because when we look at a chart like the one we're looking at now, you'll see that there's a number of different columns for the same 4-inch, 6-inch, 12-inch pipes. How do we know which one we want? Well, we need to figure out what our minimum conveying velocity is. Now, in dust collection, in order to make it work, what we do is we suck up the dust and the air, and we're moving it very fast through the ductwork. Because we're moving it so fast, the particles that are in the dust, or the dust particles in the air, are moving so fast that they stay floating and flying in the air. At a certain speed, if it goes below a certain speed, the particle will slow down enough and it will fall out and drop out of the air and settle in the ductwork. So that minimum speed we have to move. That's what we call our minimum air velocity or our minimum conveying velocity. So for woodworking, it could be a few different speeds that we need for being really specific. Really fine light dust could go at a slower speed than, say, chips or strips of wood. For that reason, we usually recommend a conservative approach and to just use a speed of 4,000 to 4,500 feet per minute in all of the dust collection system. If you do that, just about every kind of wood product, chips, strips, fine dust, heavy wet wood, dry, light, fluffy wood, whatever you're sucking up is going to stay suspended in the air, and you won't have that dust dropping out, the product building up in your ductwork or on the floors by your pickup. So that's how we take the chart that we saw earlier. because we're going to use 4,500 feet per minute as our minimum velocity we want to maintain. Now when we look at our chart, we see, 4-inch, okay, that's this speed. 4-inch pipe with 4,500 feet per minute is 395 CFM. And then I have a 6, okay, a 6 is 888 CFM. And then with that, then we simply count and add up all the sums, and then we get our final ductwork sizing. Our total airflow requirement for the system. Now, just a couple of things. When you're designing your ductwork, well, you'll often see our images like this, perhaps shown on websites. You might even download little guides that come from some OEMs that sell very simple kind of homebrew kind of systems. And they'll say things like this. They'll say things like using duct tape. They'll talk about using lots of flex hose. We want to differentiate a lot with the kinds of systems that we make. For woodworking in particular, there are a lot of people who take a very homebrew kind of amateur approach to it, even unfortunately professional companies that claim to be commercial or industrial grade. And you'll find a lot of these kinds of suggestions. And what you'll end up with is ductwork system that is very flimsy. It's not very safe. It's very inefficient. And any kind of serious woodworking application is not going to be served well by this kind of design. So things to look out for on some of those guides, where it shows sharp angles, right angles in the duct, where it shows really tight radius bends, or ducts that have many splits all right in a row. These are all things we want to avoid. We'll also talk about in a second here, resizing of the ductwork as we go through. Sometimes you'll see designs that just kind of show one long duct that all is the same size. But as we can see in our image here, balanced design, where each pickup goes up, we call that a drop point or a pickup point. And then if we're referring to the ductwork itself, we'll call that a branch. So where it drops down, you'll see here it says existing on the far left. That's one branch, right? As it goes up into the ceiling generally, where we have the main part of the ductwork, then we call that the trunk, the main line. And as you'll see, each subsequent pickup and drop point as you get closer to the collector adds into that main branch. And then you'll see the branch up in the ceiling, the trunk, it gets bigger. Why is that? Because as you add the pipes together, we need to accommodate the total airflow. So if we say, for example, that first one, that duct is a 6-inch duct. It needs 885 CFM of air. And let's say that next one now is a 4-inch duct. It needs about 485 is our 4-inch duct. 395, sorry. So now the next subsequent duct, the trunk, right, where those two come together, where the 4 and the 6 come together, we have to add the total volume of both of them together and then decide what is the proper size to make the trunk piece there going back. So a 4 and a 6 coming together might result in a 7, maybe an 8. And then we have a third pickup now that joins. And there it needs to resize up again. And you continue this pattern all the way until you get to the last pickup before we go into the dust collector. By laying it out like this with your OEM, you're going to be able to see how we design the ductwork properly so that throughout the whole system, the air velocity is always the right speed, so you don't have material building up in the ductwork. Now, again, there's a lot more involved in designing the ductwork system for your woodworking application, and that's why you're going to want to work with a reputable firm that can not only just supply equipment or resell equipment, but that actually has experience and the technical know-how to design, engineer, and lay out a ductwork system. Because the vast majority of the work in your dust collection system design is going to be designing the ductwork properly, especially for woodworking applications where there's a lot of variables on sizes, locations, even how often you use different machines. So look for someone that has particular expertise in designing ductwork systems when you're doing a woodworking application. Now, the last section we'll talk about here is now we got the ductwork design. How do we select the kind of dust collector that we need? Well, we've already done the main thing. by going with the ductwork first. We know exactly how much airflow our system needs. Now with the airflow, we can begin to decide what kind of dust collector am I going to use for my application. Now, typical dust collectors that are used for woodworking, there's quite a few different styles. Let's talk about some of them. So the most basic one that we have is a cyclone. Now, for many years, a lot of woodworking facilities, all they had were cyclones. And this is because at the time, this was acceptable with air permits for how much dust you could emit into the atmosphere, as well as for safety, for fire safety. Cyclones work by the air coming in and spinning it around really fast, and it removes a lot of the dust particles from the air without any kind of filters. Now, the problem with cyclones is that they cannot remove the absolute finest small dust. Because they can't get rid of the really fine small dust, there's a little bit that makes it out the exhaust. So in modern day 2026, there is realistically nowhere that you can have a woodworking dust collection system of any notable size that goes to just a cyclone and then is exhausted to the atmosphere. It simply is not clean enough for the environmental regulations and also for safety reasons. So oftentimes we do use cyclones still in woodworking applications, but we might use them as a pre-filter because they do remove something like 90 to 95% of all the dust, especially the bigger particles and big chunks and strips and things like that. So we do often use them as a pre-filter. Now, the second kind you might see is a medium pressure reverse air or reverse pulse baghouse. Now, these are usually practical only at larger volumes when we're like 10,000 CFM up to about 50, 60, or 70,000 CFM. These work by having a rotating arm that blows air back into the filters, and that cleans the dust off. They usually have a separate fan or a PD blower that supplies the air to clean it off. We call them medium pressure because they're usually blowing back in at something like 5 to 10 psi. Now, these systems can work very well for woodworking if they are sized conservatively. Fortunately, some manufacturers go very aggressive and they basically try to jam a lot of air into a very small dust collector to make it cheaper, and the results often don't work very well. But when they're sized correctly, these dust collectors can be a very cost-effective solution. Now, the most common type of dust collector for woodworking is a pulse jet style bag house. Now, just like the round collector, it uses filter bags. And instead of cleaning it with a medium or low pressure back pulse of air, what this does is it shoots high pressure compressed air back into the filters to clean the filters off. This is kind of the gold standard for dust collectors, and it's used across all different kinds of industries and applications, not just woodworking. So normal bag house with pulse jet cleaning are the standard. Another type of collector that you can at times use is what's called a cartridge dust collector. Cartridge dust collectors basically are pulse jet dust collectors, but instead of using bag filters, we use cartridges. Now, the picture we have here shows a cartridge collector that's a horizontal one where the filters go in horizontally. These can be used for woodworking applications, but we have to be very careful with them. Other designs have the cartridges mounted vertically so that the dust kind of wants to fall off naturally. Both kinds of cartridge collectors can be used in woodworking, but in certain specific instances. If you have any woodworking dust that has anything other than fine, pure sawdust, you want to stay away from the cartridges. Why? Because if you have chips, chunks, strips of anything, if they come flying in, they will get stuck in the pleats of the filter cartridge. And the pulsing and all that, it won't remove it. So they can very easily get plugged. You can use them on applications with that if you have a pre-filter like a cyclone to remove the big pieces. So if you do that, then yes, you have no problem using a cartridge collector. But if you only have very fine sawdust, cartridge collector can be a very economical option as well. Granted that you size it conservatively, and again, avoid OEMs or resellers that try to tell you to jam a lot of air into a very small dust collector. Now, finally, there are some specialty dust collectors out there that get used for woodworking sometimes. In the picture here, you can see some envelope collectors, which is an older design that's not used so much anymore. It's mostly been replaced by baghouse styles with round bag tubes, filters. But the other two you see, the one is a cyclone that then has filters hanging off of like an outlet header. And the other is a baghouse that has inflatable bags that has one that goes up and one that goes under. So these for many years were very common in woodworking. These are what are called enclosureless bag houses. Now, the reason we want to be careful with these, modern day regulations for environmental, but mainly for fire and combustible dust safety. These collectors are not as safe in most applications. Um, if there is a spark or a fire, you cannot have any extra kind of protection on these systems, and they will combust, and they will be full of material because they hold the material in the bags instead of discharging them like the other bag houses. So they can pose a safety hazard. It is true that in older versions of the NFPA fire safety guidelines that many municipalities and counties use for setting their fire safety standards, there was a cutout, let's say, for these older styles where they could be used on certain small systems under 5,000 CFM. Much of that has been removed, but even when there was this exemption, there were still like a number of requirements that one had to fulfill in order to use these per the fire code. Most people ignore that. So a lot of times what will happen, your medium to large woodworking application, you're looking at dust collectors, you'll get quotes, you'll get professional industrial systems quoted by, reputable firms like us or others that make, proper industrial equipment. And then somebody will come and offer you one of these things that'll be much, much cheaper and say, no, this is all you need. They're selling you something that's overkill. You don't need that. The reality is these systems no longer meet industrial commercial standards. And even if you can slip them in, they're a huge liability. So they can be bought and used in some specific, very small applications. But if you're going to look to the future, that rely on cutouts and temporary exemptions that are in a fire code that was written many years ago to try to sneak these in, they're really not the best option for you. And again, these are the enclosureless dust collectors. And then finally, after we've selected the dust collector, the last thing we're going to be looking at is the fan. So the fan design, we actually have two things we have to size the fan for. We want to talk about the amount of air that it moves. So we already have that, the volume, 10,000 CFM, 20,000, whatever it is. But the last thing we have to look for on the fan is the static pressure. The static pressure is a way of measuring how much suction power it makes or how much resistance it can overcome. So we can calculate this once we have the ductwork design. We can take the ductwork and we can calculate all of this ductwork to pull the air through it will create this many inches of static pressure. And the inches there is inches of water column or inches of water gauge. This is a measurement for resistance. It's also a measurement for vacuum and pressure that's used. So we can calculate it and we can say, okay, the entire ductwork system from the furthest point, which is usually the most constricted, all the way back to the dust collector, will create, okay, 4 inches of static pressure. Or we can say 4 inches of resistance. So we have to overcome 4 inches of resistance in order to pull the air through the duct. Now we take the dust collector and we figure out how much resistance will the dust collector at its worst moment create when it's running. So let's take a pulse jet baghouse, for example. A pulse jet baghouse we usually will run where you will have between 3 and 5 inches of differential pressure or pressure drop. Now, if you want to know more about what that means, you can look up on our website or ask us in the questions later. But essentially, the differential pressure or the pressure drop, it's the amount of resistance that the baghouse makes, the filters make when they're dirty. So what we would do for sizing the system, we would say, well, at the worst, the filters, the differential pressure is going to get up to 5. And then the cleaning system will come on and clean it down, and there'll be less resistance, right? So what we say is, okay, 5. All right, the worst case, we'll say 6, just to give us a little buffer. So at no point will the bag house create more than 6 inches of static pressure or pressure drop. So now we take the 4 from the ductwork and we take the 6 from the bag house. We put them together, we get 10. So when we talk about the fan sizing, what we need to ask is, I need a fan that is for 10,000 CFM at 10 inches of static pressure. So another way of saying that is, give me this fan, and what I need it to do is when there's 10 inches of static pressure in front of it, or it's trying to overcome 10 inches of resistance, when there's that much resistance in front of it, the amount of air it will be pulling is 10,000 CFM, because that's how much volume I need. And that's what those numbers mean on your fan. The exact amount of horsepower, the exact amount of RPMs in the fan, now that varies a lot because different models, different configurations, you get different results. But the point is not to look at the horsepower or the RPMs or any of that kind of stuff. The point is to look at how much volume of air is it moving and at what static pressure will it do that. Once you've got those 3 key components, the ductwork, the bag house or the dust collector that you're going to use, and then the fan sizing, you've already done the vast majority of the work of designing your system. Now, in our next part, Matt's going to speak to us about some other design considerations that we need to keep in mind when we're sizing and designing our woodworking dust collection system. Matt?
All right. Thank you, Dominic. Great job talking about all the various design aspects. So now I'm going to talk about some other additional design considerations specific to wood shops. So one, that I'd like to spend a minute or two talking is total cost of ownership. So there are many people who can quote a dust collector, a bag house, ductwork, etc. But it's important to kind of take some of these variables into consideration. So number one is energy costs. Oftentimes, uh, the total cost of your system will include a bag house or dust collector, ductwork and hoods, and a fan. Those are kind of the basic system components, as Dominic talked about. But there's a few things that we can do to look at energy costs. One is putting a VFD or a variable frequency drive on your fan. And so what that does is even though your fan may be rated for the total CFM or volume requirement of your shop, if you happen to be not using half your pickups and those blast gates are closed, the VFD can lower the speed of your fan so it maintains velocity without pulling the same amount of air volume and essentially uses less power during that time period. So that's an important way to save energy costs. You can also do this depending on how you set up your filter cleaning system because you're using compressed air. That air compressor uses power to keep your air header full. So depending on the timing and settings, and ideally set up your filter cleaning timer board on clean on demand mode. There's a few things that we can do to reduce your energy costs overall. Freight and installation, of course, is a factor, especially nowadays with gas prices and fuel prices going up. It's important to look at that up front. So when you do your CapEx budget, you include freight for the bag house, the cyclone, if you have one, control panel, ductwork, and so forth. Replacement filters. Um, Everybody wants to know how often should I change the filters? So the correct answer to that question, unfortunately, is it depends on how you're loading the filters, how often you're using them, etc. So a small shop that's operating on one shift might change their filters every couple of years. Uh, High volume production shop with a lot of dust that's really working their filters hard might have to change those filters every 6 months. It just depends how they're operating. There's a few things we can do to extend that. So first of all, of course, making sure you have the correct filter media, high quality filters to start with, making sure your filter cleaning system and timer board settings are correct so that you are cleaning your filters not too much, but enough to keep the dust cake from building up and keep your differential pressures under control. The other thing specific to wood shops, and you commonly see in wood shops, is putting a cyclone pre-separator upstream of your bag house. So what this does is it gets all the heavy dust out of your system. through the cyclone before it hits the filters. So this significantly reduces the load, the dust load on the filters. It's a higher cost up front because you got to put the cyclone in there, but over time, you're saving costs on uh, replacement of filters. Maintenance costs, this is one of those things that you should be planning on up front. So it's always better to be proactive and schedule and budget for maintenance activities, including filter changes, inspections, this kind of thing, rather than waiting until something seems to be going wrong in your system, because that tends to be when things get expensive. Product and device useful life. So a properly designed dust collection system for a wood shop should last for many years, decades, without having to replace any of the major components. A lot of this is going to depend on ensuring that it's designed correctly up front. So correct sizing, correct motor sizing, velocity through the ductwork, all these type of things, as well as making sure that it's maintained. So changing your filters when they require it, making sure that your pulse cleaning system is well maintained, diaphragm, valves, timer board connections, solenoids, all these things are replaced and maintained properly to make sure that overall your cost of ownership is lower. Next slide is remote monitoring. So something that we offer now is systems for monitoring your system performance and the status of your equipment using connected sensors. So whereas the old school baghouse system just had a differential pressure gauge, you go out there, check the analog dial to see how things were doing, physical inspections and so forth. Now there are relatively low cost sensors that you can put in place for differential pressure, for airflow, for your fan bearings, all these kind of things can be monitored remotely. So you can tie those into your central control system. If you have one, you can send this up to the cloud to generate reports regularly and alerts when something is going outside the limits, or we can even remotely monitor it for you and give you an alert when something needs to be addressed. For example, your differential pressure goes high, indicating that your filters need a change, or your fan vibration is trending high, indicating that the fan needs to be balanced, or maybe the bearings need to be swapped. It's much better to invest in this upfront rather than wait until the system goes down. Then you have unplanned overtime, you need to scramble for parts and so forth. So predictive maintenance, remote monitoring is kind of the wave of the future for dust collection systems and all kinds of industrial systems. So we encourage you to look closely at that. Regulatory considerations. So this is, if you're operating a business in the United States, of course, you are subject to OSHA. They have a general duty clause, which basically says that you have to make sure that your shop is safe for your workers to be in. And relevant to a wood shop, of course, that has to do with dusty atmosphere and combustible dust. So NFPA, going to the next slide here, the newest uh, iteration is NFPA 660 for combustible dust. This new revision or release incorporates a bunch of stuff that was in different NFPA standards before, including 664, which was specific for woodworking. Uh, I won't go into all the details. Every case is kind of specific. So that's why it's important that you bring in a consultant or call someone who knows and is familiar with NFPA to make sure that you get the right equipment and design elements in your system. So we would encourage you to call us. If you have a new system or you're retrofitting a system to get compliant, give us a call. Speaking of combustible dust, so the basic requirements, generally speaking, to meet NFPA requirements are you need to have explosion isolation. So if you look at the photo, you can see there's a red valve in the ductwork there upstream and downstream of the baghouse. So if you're returning air back into the building or your dust collection system is inside the building, you have to have an explosion isolation valve on both sides, the exhaust air as well as the inlet side. If you're exhausting to the atmosphere outside, you only need it on the inlet side. The idea there is that like if there's a fire or explosion in the baghouse, this valve slams shut. It prevents the flame from traveling back into the workspace. You also need to have an NFPA rated airlock or drum kit or something like that at your dust discharge to make sure that the explosion is isolated there as well. The second requirement is explosion venting. So rather than allow your baghouse of a cyclone to turn into an uncontrolled bomb, the explosion vent basically just gives it a safe passage for that explosion pressure wave and fireball to exit the baghouse in a safe direction. So this typically would need to be pointed somewhere in a safe direction that's not accessible by your employees. There's also explosion vent deflectors you can put on there so it deflects it up and away from personnel. And then finally, you have fire prevention requirements. Usually that comes in the form of a spark detection and water extinguishing system, or a mechanical fire break shutter, or some kind of a chemical suppression system. So those are the three big elements that are required in any dust collection system doing combustible dust. So if you have a wood shop, you're most likely required to comply with these. Oftentimes, you may be able to negotiate or collaborate with your local fire marshal regulator. If you have some special case to determine what makes sense in your case, the default is always to point back to the NFPA guidelines, and that's pretty much what they say. But there's also other requirements in there for housekeeping requirements, risk mitigation, and so forth, that you got to be aware of. So it's important. Don't try to wing it. Bring in someone who knows how to be compliant, so you don't get stuck answering, questions by the fire marshal, OSHA inspector, or God forbid, have some kind of a fire that goes awry. And then finally, so, we specialize in dust collection systems. We do woodworking shops all the time. I can name just a few examples here. We did one at Aberdeen Proving Grounds for the U.S. Army a year or so ago. It's a standard mid-size wood shop with cyclone with a cartridge collector. Um, the challenges of these type of projects usually have to do with getting information upfront from our customer. So if we know exactly how many machines, where they're located, what the pickup connection point sizes are, and where the dust collector will be, we're 90% of the way there. We can design a dust collection system based on that. But if we only get bits and pieces of info and we're kind of flying blind, that's where typically the design process takes a bit longer. There's potential changes and so forth. The layout changes, things like that. We find out, oh, actually, we're going to add a few pickups right here. All that impacts our design process. So the more information that you as the customer can provide us up front, the better. Ideally in the form of a layout drawing that shows all of your woodworking equipment, their position, and the pickup size. Of course, if you don't have that information, then we can help you gather it up as well. But so we do this all the time. We've done four recent federal government jobs at box shops. We've done high school wood shops, one in is it Simi Valley, I think, in LA County, small wood shops. They all follow a similar process. It's just about figuring out the system size, designing the ductwork, figuring out what the combustible dust requirements are for that system. If it's a big system, we may look at putting a cyclone as well as a fabric filter system, and then we hand off a turnkey proposal for you as a customer to review. So that pretty much sums up the kind of the design approach, the elements of that, combustible dust, all that stuff. So I think at this point, Andy, we're going to move over to Q&A.
Yes, thank you so much. Excellent explanation. Thank you. We appreciate that, Matt. So we have a Q&A section. We appreciate so much all of the questions you guys submitted. Very, very good questions. We have 11. We'll try to cover as time allows those questions. And if there's any question that you submitted in the chat box that we can get to it, be assured that we'll answer you. We'll get in contact with you and make the experts answer those questions as well. So the first one, we have Dave. He asked, how can recirculating air can be safely set up in a woodworking environment, specifically the entire unit being inside of the building, and how it can be safely designed? The heating, cooling costs associated with venting air externally can be huge. So mainly the question, how can recirculating air can be safely set up in a woodworking environment?
If you want to recirculate the air from any dust collection system back into the plant. You can do it, but it requires a number of additional considerations that you have to review. So with woodworking, the biggest thing you have to consider is fire safety and combustible dust safety. So specifically, when we say combustible dust, as we mentioned earlier, it's actually two things. It's not just do things catch on fire, but it's also explosions. And both of those can happen with woodworking dust. So if the dust, as an example, if you're sucking the air in and there is a fire somewhere between the pickup and the dust collector, right? We have to have some kind of system that stops it and breaks it so the fire cannot get pulled into the dust collector. In the dust collector, the main hazard is it exploding. So that's why we have the explosion vents on the dust collector. A fire is also bad, but explosion is much worse. So most of the requirements have to do with stopping or safely venting out an explosion. In most cases, if you exhaust the air out, the main hazard is removed. If the dust collector is outside and you're exhausting the air out, you pretty much just need three things. You need a explosion isolation valve that stops the duct, the explosion or fire from going backwards through the duct into the dust collector, or back from the dust collector back inside the building, right? Then you need the explosion vents on the baghouse, and then you need to exhaust it out, okay? And if that happens in an explosion or a fire anywhere in there, it will not propagate and become worse. If you want to recirculate in is where the problem comes, because now if there's an explosion in the baghouse, let's say, and it's running, right? You have the fan pulling air out of the baghouse and then pushing it back into the building. There's a fire or an explosion anywhere upstream, the fan will take it and push it back into the building. And that's why it's tricky when we have woodworking. So we basically have to add another layer of fire and explosion isolation on the ductwork that goes back into the building. So it's not a big deal. Sometimes we can use an abort gate, a high-speed abort gate. Sometimes we have to use a combination of a fire break shutter and an explosion isolation valve that will slam shut, but we can do it. If you put the dust collector inside the building, that's kind of related. It's not exactly the same of recirculating, but if the baghouse wants to go inside, it can be done. But again, it just makes things trickier. You generally have to have the explosion vent go outside, and you can't have a very long connection. So you'd have to put the baghouse right up against an external wall, cut a hole in the wall where you can have the explosion vent ducted just a couple of feet, like 2 or 3 feet through the wall so that it explodes and vents outside in case something happens. You could also put it inside anywhere if you want, but then you'd have to have a flameless explosion vent that would let the pressure out while snuffing out the flame front in the event of an explosion. So putting it inside and or recirculating the air back in for fire safety, it can be done. You just have to have a bit more equipment. The last thing with recirculating the air is for health and safety inside, kind of also related to the fire safety as well. Because if you're running the dust collector and something should happen, let's say you suck up a nail or a piece of metal or something, and it cuts a hole in one of the filters. Now the filter is going to be leaking, so dust is going to get by and go through the fan and exhaust it out. If that happens and all you do is exhaust the air out, you just blow dust outside, you get in a problem maybe with the county for an air permit violation, or you can quickly see it, fix it, and nobody's the wiser. If you're recirculating the air back in, though, all of that dust that leaks just gets blown right back into your building. Now in woodworking, that's bad, especially bad because you have combustible dust. Now you're recirculating it back in. You're basically blowing in combustible material and depositing it nicely all over your building, especially on like elevated surfaces, like on top of machines, rafters. So in that case, sometimes it's required, sometimes it's not required, but it certainly is a great idea, is you need something in the event that you have a leak in the filters. So traditionally what they do is they have you put HEPA after filters so that after it goes through the filters in the baghouse, goes through the fan, and then you blow in, it goes through a set of HEPA filters that don't really do anything because the dust collectors already captured everything, but they're there in case you ever have a leak in the filters in the dust collector. And they capture everything so nothing gets into the plant. A little riskier, but a viable and reasonable way to do it instead of the HEPA filters is to have a very sensitive bag leak detector or filter leak detector in the ductwork after the filters. So that way, if you get any leakage, it'll go off right away, and you can shut down and go take remedial action to change the filter or whatever it is. Sometimes we can combine that with a abort gate so that if it detects a certain amount of dust coming by, the abort gate will slam shut and open on the top, and it'll blow all the air out to the atmosphere. So you do have a problem, but you will not be blowing dust back into the building in any case. So if you do those couple of things, you can make the recirculating the air absolutely possible. And a lot of our customers do that, and we're able to help them with that. It just requires that extra investment and it just makes the system a little bit more complicated. But in places where you have a lot of heating and cooling costs, or you need to really control the humidity inside, for example, I work with a couple of major guitar manufacturers, and controlling the humidity level inside the building is so important that for them it's worth it to have all these extra devices and extra procedures because just dumping all of that conditioned air out into the atmosphere is a huge waste of money. So for them, it makes sense. Have it go back in and add these couple extra safety devices and procedures, and then there's no problem.
All right. So the other question is, uh, can a dust collection system be over-designed to avoid issues if a branch is added later?
So the short answer is yes. When we design a dust collection system, we like to design conservatively. So if we add up all your pickup points and you need 5,000 CFM, we're not going to propose a 5,000 CFM fan and a baghouse that will just barely make it with for 5,000 CFM. Usually we'll have a safety factor of 10% or more. I'd say 10% at a minimum. And then if you think you're going to add some pickup points later, then certainly we would add a safety factor. We bump that up a little bit. It is important to keep in mind that when you add a pickup, it changes the calculations on the ductwork fairly significantly. So even if your fan is big enough, your baghouse is big enough, if you just kind of willy-nilly add, drops here and there, this balance of your system is going to change. You may end up having, you may starve the other pickups depending on your airflow capacity. You might end up with your velocity through the ductwork that's already there being too fast or too slow. So you might be wearing out elbows or having dust sowing. So it's important that if you're going to make changes to the ductwork, that you have a professional come and look at it and properly engineer it. Changes can be made. It doesn't have to be a huge science project, but it is important to note that you're changing the ductwork balance. So I wouldn't do it casually.
Good. Okay, next question. What type of damper is typically used to balance dust collection systems?
So a damper is just any kind of gate or valve that lets you partially or fully close off the duct. We usually refer to these as blast gates, but there are barometric dampers. There are other kinds that are used in ductwork. The terminology is kind of loose, but basically it's some kind of gate or valve that partially opens things up. Balancing the dust collection system is important because if you just hook up a whole bunch of things, um, because different branches are smaller or longer or have more twists and turns, they end up with more resistance. So the fan doesn't know that you want this much airflow here and this much airflow here. It's just going to pull air, and the branches that have more resistance to them will have less air pull through them, basically. So sometimes if you have multiple pickups, you get more in one spot than you think you want, and you get less over here where you need it. So then balancing is where we basically, with the gates, on a branch that has too much air going through it because let's say it's close to the dust collector, it's just open, very low resistance to that branch. What we would do is with the gate is we would partially close off the duct and artificially create more resistance there. And then because now that branch has more resistance, the air is going to look for the path of least resistance, and it's going to kind of, we can think of it as be diverted over to the other pickups. So always a good idea when you have multiple pickups, include a basic blast gate on all of the pickups at the ends, because you can always use them to balance a little bit. And if you ever need to close it off completely for some reason, you have the gate there, you can do that too. If you want a really advanced system, we can do systems that have automatic glass gates where if the machine is on, the gate opens or closes. If you go really advanced, you can get gates that to maintain a certain airflow based on how many gates are open, it will automatically turn the fan speed up and down so that you get consistent airflow all through. Those are auto gate systems, and those can get very very useful when you have a lot of machines. But it is an investment, so if you want to look at something like that, please talk to us, and we can take a look at your system and see if it's a good fit for that. If by damper, though, what you're meaning is the damper on the fan, um, that would be a damper that's used to artificially create pressure on the fan so that it pulls less air. That could be part of balancing a system, but generally, when we say balancing the dust collection system, we're talking about the ductwork upstream of the dust collector, not controlling how much air the fan is able to produce.
Good. Excellent. So next question, how can blast gates be used in smaller applications like school woodworking shops to assist with balancing?
Yeah, kind of going back to the same thing. They're used all the time. So if we, depending on what the customer wants, oftentimes we will have blast gates that are on every single pickup. So, maybe the customer has a very small system. They don't, their budget is limited. They're only planning to use one or two pickups at a time, and they want to, conserve by closing off the pickups that are not in use. We'll just put a blast gate or a slide gate on every single pickup. The customer can use it. There is a caveat, a warning, I would say, when you do that, depending on how the ductwork is designed, you do run the risk of starving the trunk line and having dust settling and so forth when you're opening and closing pickups. But, it happens all the time. People do it. You just have to be aware of it.
Awesome. From your experience, how much extra capacity should engineers consider when selecting a fan?
I generally recommend people do anywhere from 15 to 25% extra capacity. Um, Part of that is in case they want to add something later, because almost everybody wants to add things later, and you can never make a baghouse bigger once it's in. So much better to make it a little bit oversized. I also always just recommend we oversize it a little bit anyway, in case some of the calculations are off, either yours or in the process of installing things, we have to reroute something or add another thing here or split something. Having that little bit of a cushion is always a nice thing to have. And it just always, it takes the dust collector from being, basically red lined under 100% stress that it's designed for. When it's at 80 or 90% of the stress it's designed for, the difference in performance is huge. It'll work a lot better. So I always recommend 15 to 25%.
Awesome. All right. It says, do explosion vents come standard with dust collectors, or do they need to be specified during selection?
They do not come standard. They're commonly added. It's kind of an optional adder for a regular dust collector. The way they are sized, first you have to go do a dust hazard analysis. So you take a sample of your dust, you send it over to the lab for a DHA. They'll give you all the dust explosivity values, the Pmax and KST and all this stuff. Using that and the volume of your bag house, you can calculate the size of the dust vent. And it is important that you have someone knowledgeable do that, because if you undersize them, of course, then you're not adequately venting. If you oversize them, you may be overpaying a little bit. But there is a process and an equation basically for calculating vent size.
All right, so the next question is, how do I determine the correct airflow required to each woodworking machine in my facility?
As we said earlier, most of the machines that you're going to have, the manufacturer of that machine has already determined how the venting of the hood design is and how much airflow it needs. That's what we call the ventilation design. They've already done all of that. So the clue that they leave you, if they don't write it in the manual, the clue they leave you is what size port is there on the back of the dust collect on the machine. So if they have a 4-inch port there, what they're telling you is, okay, hook up this 4-inch port with the velocity of the air velocity that's used for woodworking dust collectors, which, as we said, 4,000, 4,500 feet per minute is very conservative. If you hook up a 4-inch and you move the air that fast through the 4-inch pipe, then you'll figure out the airflow by looking at the chart, like we said, 485 CFM for 4 inch, for example. Sometimes you find in the manuals and things like that, but it's not very often. And then you just add up all of the ports together, and that's how you end up with the total CFM you need. If you don't have dust collection built into your machine already, you need to consult with us, and we need to see how it makes dust and all those things. And we might have to come up with a custom hood for you, and then that can vary a lot how much the airflow is. But that's not so common with woodworking applications. So most of the time, you've already got it there. You just need to find the port size and then apply that formula that we talked about earlier.
Awesome. Next question. What are the warning signs that a dust collection system is undersized or not performing properly?
So classic warning signs that your system is undersized or not performing properly. So the basic kind of functional metric for a baghouse or dust collection system is the differential pressure. So that's the pressure across your filters. Usually, they're designed to operate between 2 and 5 inches water. That's kind of the pressure range you're looking for. If you go out and you look at your bag house and it pinned at 10 inches, or maybe it's 6 to 8 inches, what it's telling you is that your filters are blinded or your filter cleaning mechanism is not functioning, and it's like a big warning red light for your system. So answer number one is differential pressure too high. That's a big warning sign. Functionally, when you start to lose suction at your pickup points, when you get your brand new system, everything is, great suction and airflow. It's just pulling the dust right out of there. Everything's good. You come back a couple years later and maybe it's not sucking so much. You're not getting the airflow you need. It's dusty in your shop. That would be sign number two. And usually I would say the two are related. So your suction is lower because maybe your differential pressure is higher. You may have accumulated dust in your ductwork over time, so you should probably have an inspection done to make sure you clean out your ductwork. Or maybe there's some other issue going on where your fan is not pulling as much air as it should be. So that's where we would point you back to our like the standard quarterly or daily, monthly, quarterly, yearly checklist type of items. But if you have nowhere else to start, check the differential pressure on your baghouse.
Great. Awesome. Very thorough answer. Excellent. The next question, are floor sweeps a good idea in woodworking facilities, or can they create problems in the dust collection system?
This almost sounds like a loaded question, but so there's floor sweeps are very convenient for shop operators because when they clean up their shop, they just sweep up everything into the floor sweep. That's great. It's convenient. I would want one if I was there working a saw all day. There is definitely a downside to floor sweeps, and that is that everything that gets swept up into them will go into your bag house, into your dust collection system. So we just finished a job at the Marine Corps Logistics Base box shop. We pulled the old system apart, and the trunk line was half full. It was like a 24-inch trunk line, halfway full with nails, staples, gloves, uh, chip wrappers, trash, all kinds of stuff. So you can imagine, if you're pulling nails into a fabric filtration system or even into a cyclone, and it's going out through a rotary airlock, it's just going to wreak havoc on your system. So if I had to pick one, I'd say no floor sweeps. It's just there's too much risk of messing up your dust collection system. I get it. They are convenient. Yeah, if you really trust your shop personnel to not sweep up nails and trash in there, then go for it. But I guess don't be too surprised when you get some bad stuff in the dust collection system.
Awesome. All right. How do you properly size duct branches when multiple woodworking machines operate intermittently rather than continuously?
Yes, you can design your system for pickups that are used intermittently. When you first provide the basic layout and list of machines to us, we will often ask you to specify whether these machines will be used continuously or intermittently. Based on that discussion, we may design the system a little bit smaller than normal to account for the fact that not everything's always going to be running. The ideal thing would be if you have, let's say you have 10 machines, 7 of them are running all the time, 3 of them you only use once in a while. Or maybe you have a combination like, okay, you run 5 of them all the time, and 5 of them you only run occasionally, but when you run those 5, you don't run the other 5. Those kinds of things you need to discuss with us or your dust collector OEM who's designing your ductwork and sizing everything. Generally speaking, the best would be to just design the system big enough to run all of it at the same time. But if you're really confident that that's not necessary, we can usually meet you somewhere in the middle. So if you have 10, if you only run 5 all the time, I wouldn't suggest we size it exactly to the 5 because we have problems with getting the ducting the right size for the velocities with all the connections. But generally what ends up happening is we meet you somewhere in the middle where like it's like 7. So it does end up saving you a little bit. But yes, absolutely. You can design branches of the duct and the dust collection, the dust collector and fan with that in mind. And you're only going to run some machines intermittent.
And the last question. What type of filter media is typically recommended for softwood versus hardwood dust?
I might let Dominic take a stab at this. My initial thought is that, polyester, standard 16-ounce polyester filter media is probably fine for both. In almost all cases, it'll be just fine. You might have some case where you're using polypropylene, but for wood shops, we're not talking really high temperatures. We're not talking really abrasive dust. There's not a lot of moisture. And those are kind of like the three big things that drive filter media selection. So I would say it's not going to matter that much, but I might let Dominic, he knows more about the filter media, so maybe let him take a stab at that one.
All right. Okay, Dominic, do you have any insights on that question?
Yeah, no, Matt's on the right track there. It really doesn't matter with regards to hardwood versus softwood. Um, Polyester bags, if you have a bag house, is the standard. And then if you have cartridges, we usually recommend the spun bond polyester cartridges because they're open more. There's more spacing between the pleats. But that's for physical characteristics. You have the nano, the 80/20 with the nano on top. I mean, that's not going to matter. Softwood versus hardwood, that doesn't have any impact. What has an impact are things like moisture, things like if there's any kind of oils, resins, or treatments on the wood, things like if there's high humidity because you're in a humid area or it's coming off of like a dryer or something like that, some kind of process, and you have a lot of moisture that's in the air and it's hot and sticky. Like those things matter about picking the media, but just all things being equal, softwood versus hardwood doesn't make a difference.
Great. Thank you, Dominic. Fantastic. All right. So those were all the questions. We have no more time. We appreciate your attendance and your participation as well with all those questions. Great questions we covered. As we mentioned, you will receive the link to watch this webinar on demand and share it with whomever you think will enjoy it. And on behalf of all the team at backhouse.com, we thank you again for your disposition, your attendance. And if you have any additional questions, feel free to call us. There in the main screen, we have the contact information if you want to email us or call us as well. So thank you so much and have a great rest of the day. Goodbye.